Yes, we are going to discuss the last section of chapter 11. And let me present. The section 10 deals with the Taylor series and the Maclaurin series. We know that a function fx may be written as fx is equal to c0 plus c1 times x minus a plus c2 times x minus a the whole square plus c3 times x minus a the whole cubed plus etc. This is the power series expansion centered at x is equal to a. So fa is equal to, if you want to find fa, you substitute x is equal to a. So the second term is 0, third term is 0, fourth term is 0, every other terms are 0. The only remaining non-zero term is the first one, C0. So fa is equal to C0. Now you differentiate. F prime x is equal to C0 is a constant, so its derivative is 0. C1 times x minus a is C1 times 1 minus 0, so that is C1, plus C2 times 2 times x minus a plus C3 times 3 times x minus a the whole square plus etc. Now you substitute x is equal to a, so f prime a is equal to C1. Differentiate f prime x once again, you get f double prime x is equal to 2 times C2 times 1 plus 3 times 2 times C3 times x minus a plus etc. Again substitute x is equal to a, you get f double prime a is equal to 2c2, or c2 is equal to f double prime a divided by 2. Differentiate f double prime a once again, you get f triple prime x is equal to 3 times 2 times 1 c2. I mean f double prime x c 3 times 2 times 1 times c3. This is a c3. And here it is a C4, 4 times, 3 times, 2 times x minus C4 times x minus a plus etc. So this is C3, not C2. C3 is equal to f triple prime a divided by 3 factorial. Therefore, fx is equal to fa plus f prime a over 1 factorial. That is C1. C1 is f prime a. C2 is f double prime a over 2 factorial. F3 is f triple prime a over 3 factorial plus etc. And so this is called the Taylor's expansion. Fx is equal to fa plus f prime a over 1 factorial times x minus a plus f double prime a over 2 factorial times x minus a the whole square plus f triple prime a over 3 factorial times x minus a the whole cubed plus etc. This is called the Taylor's series. In particular, when a is equal to 0, the series becomes fx is equal to f0 plus f prime 0 over 1 factorial times x plus f double prime 0 over 2 factorial times x square plus f triple prime 0 over 3 factorial times x cubed plus etc. This is called the Maclaurin series. Derivation is not very important, but you have to memorize the result. So, first one is fx is equal to fa plus f prime a over 1 factorial times x minus a, because it is centered at a, plus f double prime a over 2 factorial times x minus a the whole square plus f triple prime a divided by 3 factorial times x minus a the whole cubed plus etc. That's the Taylor series. Then the Maclaurin series, you replace a by 0. Fx is equal to f0 plus f prime 0 over 1 factorial times x plus f double prime 0 over 2 factorial times x square plus f triple prime 0 over 3 factorial times x cubed plus etc. First, we will do some examples. These examples are not from the book. First one is fx is equal to e to the x. We are going to establish an infinite series for e to the power of x. F0 is e to the power of 0, that is 1. F prime x is again derivative of e to the x is e to the x. So f prime 0 is 1. Then f double prime is again e to the x. F double prime 0 is 1. F triple prime 0, f triple prime x is e to the x. So f triple prime 0 is e to the 0, that is 1, etc. So by Maclaurin's series, e to the x is equal to f0 plus f prime 0 over 1 factorial times x plus f double prime 0 over 2 factorial times x square plus etc. So that is 1 plus 1 over 1 factorial fx plus 1 over 2 factorial x square plus 1 over 3 factorial x cubed plus etc. So that is e to the power of x is 1 plus x over 1 factorial plus x square over 2 factorial plus x cubed over 3 factorial plus etc. This is also known by the name exponential theorem. So e to the x is 1 plus x over 1 factorial plus x square over 2 factorial plus x cubed over 3 factorial plus etc. Now let us see for what value of x this series is valid. So you find limit n approaches infinity, an plus 1 over an. An is x to the n over n factorial. So an plus 1 is x to the n plus 1 over n plus 1 factorial. So this is limit n approaches infinity, x to the n plus 1 over n plus 1 factorial times n factorial over x to the n. That is limit x numerator x to the n plus 1 minus n plus 1 minus n, that is x to the 1, which is x denominator. All the terms in n factorial cancels because n factorial is 1 times, 2 times, 3 times, 4 times, etc. up to n. N plus 1 factorial is 1 times, 2 times, 3 times, etc. times n plus 1. So all the terms up to n cancels, the leftover is just n plus 1. So limit n approaches infinity, x over n plus 1, as n is infinity, this is x over infinity, which is 0. And that is always less than 1. So this is less than 1 for all values of x. So the interval of convergence is negative infinity to infinity and the radius of convergence is infinity. That means this theorem is valid for all values of x. Example 2, logarithm, natural log of 1 plus x. Okay, f0 is natural log of 1 plus 0, that is natural log of 1, which is 0. F prime x is 1 over 1 plus x. So f prime 0 is 1 over 1 plus 0, that's 1. F double prime x is negative 1 over 1 plus x the whole square. So f double prime 0 is negative 1. F triple prime 0 is 2 over 1 plus x the whole cubed. If you do not remember the formula, you convert this into negative 1 times x plus 1 the whole to the negative 2 and apply the power rule of differentiation. So f triple prime 0 is equal to 2 divided by 1 plus 0, that is 2. Similarly, fourth derivative of fx is negative 6 over negative 2 times negative 3. That's negative 6 over 1 plus x to the 4. So f fourth derivative at x is equal to 0 is negative 6 and so on. And therefore, you get fx is equal to f0, this is a formula, f0 plus f prime 0 over 1 factorial plus f double prime 0 over 2 factorial times x square. I repeat, f0 plus f prime 0 over 1 factorial times x plus f double prime 0 over 2 factorial times x square plus f triple prime 0 over 3 factorial times x cubed plus etc. And f0 is 0, f prime 0 is 1, so 1 over 1 factorial times x plus negative 1 over 2 factorial times x square plus 2 over, because x cubed 3, f triple prime is 3, 2 over 3 factorial times x cubed plus negative 6 over 4 factorial times x to the 4 plus etc. So that is equal to x. 1 over 1 factorial is 1, so this is x. Then you have a minus 1 over 2 factorial, that is minus 1 over 2. 2 factorial is 2. Then the next one is 2 divided by 3 factorial. 3 factorial is 1 times 2 times 3. So 2 cancels. You get x cubed over 3 minus x to the 4 over 4. 4 factorial is 24. 6 divided by 24 is 1 over 4. Plus x to the 5 over 5 minus x to the 6 over 6 and so on. So keep that formula in mind. Natural log of 1 plus x is equal to x minus x square over 2, no factorial, x square over 2 plus x cubed over 3 minus x to the 4 over 4 plus x to the 5 over 5 minus x to the 6 over 6, etc. And interval of convergence. So an is negative 1 to the power of n minus 1 x to the n, and varies from 0 to infinity. So no, n varies from 1 to infinity. N varies from 1 to infinity. So n is equal to 1. Negative 1 to the power of 1, 1 minus 1, 0. So that's a positive x. N plus 1 is negative 1 to the power of n, x to the n plus 1 over n plus 1. Therefore, limit an plus absolute value of n plus 1 over n is equal to limit n approaches infinity, negative x to the power of n plus 1 over n plus 1 times n over x to the n. That is limit n approaches infinity, absolute value of x. You can simply discard the negatives because you are finding the absolute value. So n, this is absolute value of x, which is less than 1. This is not an actual cancellation. N divided by n plus 1, you divide numerator and denominator by n. So you get 1 over 1 plus 1 over n. So that is why it is 1 over 1 plus 0. I skipped 1 or 2 steps there. So that is equal to limit n approaches infinity, absolute value of x must be less than 1. So radius of convergence is 1 and interval of convergence is negative 1 to 1. What does it mean? It means this series is valid, this expansion is valid only for a value of x that lies between negative 1 and positive 1. And if it is between outside that limit, it is not valid. In fact, it is true for x is equal to 1, but it's beyond the scope of our syllabus. It is not true when x is equal to negative 1, because when x is negative 1, it becomes 1 minus 1, which is natural log of 0, which is negative infinity. But x is equal to 1, it is natural log of 2, and that works here. Natural log of 2 is 1 minus 1 half plus 1/3 minus 1/4, etc. Anyway, this is the expansion of natural log of 1 plus x, and the interval of convergence is negative 1 to 1. Number 3, sin x. Fx is equal to sin x, so f0 is equal to sin 0, which is 0. Differentiate, f prime x is cos x, so f prime 0 is 1, cos 0 is 1. F double prime 0 x is equal to negative sin x, so f double prime 0 is 0. F triple prime x is negative cos x, so f triple prime x is 0 is negative 1. Fourth derivative is sin x, so fourth derivative at x is equal to 0 is 0. Fifth derivative is cos x, so fifth derivative at x is equal to 0 is 1, and so on. You write a few more. I wrote it here up to 8. Now use the formula. Fx is equal to f0 plus f prime 0 over 1 factorial times x plus f double prime 0 over 2 factorial times x square plus f triple prime 0 over 3 factorial x cubed plus etc. This is a Maclaurin series. Now you replace, every other term are zeros. First term is 0, second is non-zero, third is 0, and so on. So when you remove all the zeros, you get sin x is equal to x over 1 factorial minus x cubed over 3 factorial plus x to the 5 over 5 factorial minus x to the 7 over 7 factorial, etc. So that is the power series expansion for sin x. And now let us try to find the interval of convergence. Limit n approaches infinity, an plus absolute value of an plus 1 over an. We are thinking about absolute value, so discard all the negative sign. It is going to be x to the 2n plus 1 over 2n plus 1 factorial times 2n minus 1 factorial over x to the 2n plus 1, and that becomes 2n minus 1. So it becomes x square 2n plus 1 minus 2n minus 1 is 2. And similarly, 2n minus 1 factorial and 2n plus 1 factorial cancels, and there leftover is the last two terms in the denominator. Last term is 2n plus 1 and immediately preceding term is 2n because they differ by 1. So 2n plus 1 factorial is 1 times, 2 times, 3 times, 4 times, etc., times 2n minus 1 times 2n times 2n plus 1. So terms up to 2n minus 1 cancels, leaving 2n times 2n minus 1 in the denominator. So when n is infinity, denominator is infinity. So the answer is 0, which is always less than 1. Therefore, radius of convergence is infinity and interval of convergence is negative 4. Cos x. Same process. f0 is equal to cos 0, that's 1. F prime x is negative sin x, so f prime 0 is 0. F double prime x is negative cos x, so f double prime 0 is negative cos 0, that's negative 1. F triple prime x is equal to sin x, so f triple prime 0 is 0. Fourth derivative is cos x, derivative of sin x is cos x. So fourth derivative at x is equal to 0 is 1. And you repeat this. I have written only up to f6. You may write up to f6 or f8. And now the Maclaurin series is fx is equal to f0 plus f prime 0 over 1 factorial times x plus f double prime 0 over 2 factorial times x squared plus f triple prime 0 over 3 factorial times x cubed plus etc. First term is a 1. Every other terms are zeros. So 1 minus x square over 2 factorial plus x cubed over x to the 4 over 4 factorial plus etc. Just recall the two series of sin x and cos x. Sin x starts with x over 1 factorial minus x cubed over 3 factorial plus etc. Alternate positive and negative. Cos x also same kind of, but all the exponents are even numbers. Previous case, all the exponents are odd numbers. And as in the previous case, you find the interval of convergence. You will see it's exactly similar. So n is negative 1 to the power of n, x to the 2n over 2n factorial. An plus 1 is negative 1 to the n plus 1, x to the 2 times n plus 1 divided by 2 times n plus 1, which is 2n plus 2 factorial. Find the ratio. You get negative x square over 2n times 2n plus 1. I explained it in the previous question. And therefore, limit n approaches infinity, absolute value of an plus 1 over n is equal to limit n approaches infinity, x square over 2n plus 1 times 2n. Answer is 0 because it is x square over infinity. So answer is 0, always less than 0. Therefore, interval of convergence is negative infinity to infinity, and the radius of convergence is infinity. So these are the 4 most popular infinite series, most popular functions. I think it is not in the book. So these 4 are e to the x, natural log of 1 plus x. Of course, natural log of 1 minus x may be taken out of that. E to the negative x may be taken out of that. Cos x and sin x. Now, this is number 6 from the textbook. You have to find first 4 non-zero terms, that's all. So fx is 1 over 1 plus x. A is equal to 2, centered at 2. Therefore, f of a is f of 2, that is 1 over 1 plus 2, which is 1 over 3. F prime x, negative 1 over 1 plus x the whole square. So f prime 2 is negative 1 over 1 plus 2 the whole square. This is 3 square. So negative 1 over 9. Double prime. F double prime x, 2 over 1 plus x the whole cubed, because it is positive. As I mentioned earlier, if you do not remember the formula, write this as negative 1 times 1 plus x to the negative 2, and then use the power rule. After 1 or 2 steps, you get this. That implies f double prime 2 is equal to 2 over 3 cubed, which is 2 over 27. For next term, f triple prime x is negative 2 times 3. 2 times negative 3, that's negative 6, over 1 plus x the whole to the 4. So f triple prime 2 is negative 6 over 3 to the 4, which is 81. Negative 6 over 81, 3 cancels. So negative 2 over 27. So you have first 4 terms here. So first 4 terms is 1 over 1 plus x is equal to fa, which is f2, plus f prime 2 over 1 factorial times x minus 2, the first formula. This is the Taylor series, not the Maclaurin series. Times plus f double prime 2 over 2 factorial times x minus 2 the whole square, plus f triple prime 2 over 3 factorial times x minus 2 the whole cubed, and you replace f2, f prime 2, f double prime 2, and f triple prime 2. So you have first 4 non-zero terms here, 1/3 minus 1 over 9, minus 1 over 9 over 1 factorial plus 2 over 27 over 2 factorial times x minus 2 the whole square, minus 2 over every other terms are negatives, 2 over 27 over 3 factorial times x minus 2 the whole cube. Number 8, question is the same. Find the first 4 terms. First non-zero terms. First 4 non-zero terms. Fx is equal to natural log of x centered around x is equal to a. So f1, fa is equal to f1 is natural log of 1, which is 0. Then f prime x is 1 over x. F prime 1 is 1 over 1, which is 1. F double prime x is negative 1 over x square. So that is negative, f double prime 1 is negative 1. F triple prime x is 2 over x cubed, because negative 1 times negative 2 over x cubed, that is 2 over x cubed. So f triple prime 1 is equal to 2 over 1, that is 2. Fourth derivative of x is negative 6 over x to the 4. So for f4, fourth derivative at x is equal to 1 is negative 6. Therefore, fx is equal to fa plus f prime a over 1 factorial, etc. That is the Taylor series. So natural log of x is 0 plus 1 over 1 factorial. F prime a is f1, 1 over 1 factorial, minus 1 over 2 factorial times x minus, I repeat, 0 plus 1 over 1 factorial times x minus 1 minus 1 over 2 factorial times x minus 1 the whole square, plus 2 over 3 factorial times x minus 1 the whole cubed, minus 6 over 4 factorial times x minus 4 the whole to the 4. And on simplification, you get x minus 1 minus x minus 1 the whole square over 2 plus x minus 1 the whole cubed over 3. 3 factorial is 1 times 2 times 3, and 2 cancel. So their leftover is 3. Similarly here, 4 factorial is 1 times 2 times 3 times 4. So 2 times 3 is 6. That cancels. So leaving a 4. So these are the first 4 non-zero terms. Okay, number 10 is a little long, but not difficult. Cos x is equal to, fx is equal to cos square x. Around a is equal to 0. So that is convenient actually. So around a is equal to 0 means it is you are using the Maclaurin series. And start with f of 0. F of 0 is cos square 0. That is 1. Now f prime 0 is negative 2 cos x sin x, because Derivative of cos square x is 2 cos x times derivative of cos x, that is negative sin x. Trig identity, 2 sin x cos x is sin 2x, so that is negative sin 2x. So f prime 0 is negative sin 0, which is 0. F double prime x is negative 2 cos 2x, negative of cos 2x times 2 chain rule. Substitute x is equal to 0, so f double prime 0 is negative 2 times 1, cos 0 is 1, negative 2. F triple prime 0, x is 4 sin 2x. Substitute x is 0, you get 0. F fourth derivative is 8 cos 2x. So fourth derivative at x is equal to 0 is 8. Fifth derivative is negative 16 sin 2x, because 8 times negative sin 2x times 2. So that becomes negative 16. So at x is equal to 0, fifth derivative is 0. Sixth derivative is negative 32 cos 2x. So sixth derivative is 32. So we have 1, 2, 3 non-zero. We need one more. You're asked to find 1, 2, 3. Okay. Oh no, we have 4 terms. The f0 is 1. So 1, 2, 3, 4. 4 non-zero terms. So that is equal to cos square x is equal to 1 minus f1 plus f0 plus f prime 0 over 1 factorial, which is 0, minus plus f double prime 0 over 2 factorial, that is negative 2 over 2 factorial, x square plus x to the next term is 0, so that is 8 over 4 factorial over 4 factorial times x to the 4 minus next term is 0, the next is negative 32 minus 32 times x to the 6 over 6 factorial. See, 8 over 4 factorial is simplified here. 8 divided by 1 times 2 times 3 times 4. 2 times 4 is 8, that is 1/3. Similarly, 32 over 6 factorial is simplified here. That is 32 over 1 times 2 times 3 times 4 times 5. So that is 4 times 2 is 8. No, 4. 1 times 2 times. Let us work out that question. 32 divided by 6 factorial, that is 720. Or 45. So that is 2 over 45. There was a 6 here. Okay, so that reduces to 2 over 45. So the final answer is cos square x is equal to 1 minus x square. 2 over 2 factorial is 1. So x square plus 1 over 3 x to the 4 minus 2 over 45 x to the 6. Those are the first 4 non-zero terms. Question number 14. Fx is e to the negative 2x. So f0 is e to the 0, that's 1. F prime x is negative 2, e to the negative 2x, because derivative of e to the x is itself. So e to the negative 2x times negative 2. F prime 0 is negative 2 times e to the 0, that's negative 2. Double prime x is 4 times e to the negative 2x, that's negative 2. Times e to the negative 2x times negative 2. So it becomes positive 4. So f double prime 0 is 4. F triple prime x is negative 8 e to the negative 2x. So f triple prime 0 is equal to negative 8. Fourth derivative is 16 times e to the negative 2x. So f fourth derivative at x is equal to 0 is 16. I think those terms are enough. You need only 4 terms. No, you're asked to find several terms. So I went up to 6th. Therefore, I have written up to 6. E to the negative 2x is 1 minus 2x over 1 factorial plus 4 over 2 factorial over times x square minus 8 over 3 factorial times x cubed plus 16 over 4 factorial times x to the 4 minus etc. So you may write it, if I ask a question like this for the test, you can stop at this line. You don't have to write in the some sigma notation, but that is sigma notation is a standard form. Sigma n varies from 0 to infinity, negative 2 to the power of n. You see here 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, and so on. So negative 2 to the power of n times x to the n over n factorial, and that is the expansion of e to the negative 2x. Now, when it is valid, so that is another part of the question. So you write nth term, negative 2 to the power of n, x to the n over n factorial, n plus 1, the term is going to be negative 2 to the power of n plus 1 times x to the n plus 1 over n plus 1 factorial. Now you find the ratio. N plus 1 over n is equal to negative 2 to the power of n plus 1 x to the n plus 1 over n plus 1 factorial times reciprocal of n, that is n factorial over negative 2 to the power of n over x to the n, and that is negative 2 to the power of n plus 1 minus n, that is negative 2 to the power of 1, which is negative 2. X to the power of n plus 1 minus n, that is x to the 1 divided by n plus 1, n factorial means 1 times, 2 times, 3 times up to n. Here, n plus 1 factorial means 1 times, 2 times, 3 times n plus 1. Times up to n cancels, leaving n plus 1. So that simplified answer is negative 2x over n plus 1. So limit n approaches infinity, absolute value of n plus 1 over n is equal to limit n approaches infinity 2x over n plus 1, which is 0, because denominator is infinity. That is always less than 1. Therefore, interval of convergence is negative infinity to infinity, and the radius of convergence is infinity. Okay. Okay, number 16. X times cos x. F0 is 0 times cos 0, which is 0. Differentiate f prime x is negative x times negative sin x plus cos x, product rule. F prime 0 is, first term is 0, cos 0 is 1, first term is 0. Again, f double prime x is, differentiate this, negative x times cos x minus sin x times 1, so that is minus cos x minus sin x, you get minus x cos x minus 2 sin x. F double prime 0 is 0, because here x is 0, here sin 0 is 0. Triple prime, differentiate once again, you get x sin x minus 3 cos x, because x, negative x times negative sin x, so that is x sin x. Then cos x times negative 1, that is negative cos x, and here another 2 cos x. So x sin x minus 3 cos x, so that f triple prime is, first term is 0, second term is negative 3 times 1. That is f triple prime 0 is negative 3. Fourth derivative is x cos x plus 4 sin x. Now there is a pattern, you follow that pattern. So f fourth derivative at x is equal to 0 is 0. Fifth derivative is negative x sin x. See, similar to this, negative x sin x plus 5 cos x. Substitute x is equal to 0, you get a 5. Now differentiate. Sixth derivative is negative x cos x minus 6 sin x. So sixth derivative at x is equal to 0 is 0. Seventh derivative is x sin x minus 7 cos x. So that it becomes -7, eighth derivative. So, okay, that's enough. So you use the formula. This is Maclaurin series. Fx is equal to f0 plus f prime 0 over 1 factorial times x plus f double prime 0 over 2 factorial times x square plus f triple prime 0 over 3 factorial times x cubed plus etc. So x cos x is, first term is 0, second term is f prime 1, f prime 0 is 1. So 1 over 1 factorial times x. Next term is 0. Next term is -3. Here it is. -3 over 3 factorial x cubed. Next term is 0 plus 5 over 5 factorial times x to the 5. Next term is 0. Minus 7 over 7 factorial times x to the 7, etc. So that is simplified. X over 1 factorial. Second and third term is 0. Minus 3 over 3 factorial is 2 factorial. So x minus x cubed over 2 factorial plus x to the 5 over 4 factorial minus x to the 7 over 6 factorial, etc. And when is it valid? You apply the same technique. N is, it's sigma notation, sigma 0 to infinity, -1 to the n, x to the 2n plus 1 over 2n factorial. And so n is -1 to the power of n, x to the power of 2n plus 1 over 2n factorial. N plus 1, you have to increase n by 1. So n numerator becomes 2n plus 1, 2 times n plus 1 plus 1, that is 2n plus 3. Denominator 2 times n plus 1 factorial, that is 2n plus 2 factorial. Now find the ratio and take your own time and work on it, because we have done several problems of the same kind. So you get negative x square, x to the 2n plus 3 minus 2n minus 1 is going to be 2, divided by here also 2 terms. The last 2 terms will stay there. That is, last term is 2n plus 2, because this is 2n plus 2 factorial. Immediately preceding term is 1 less than that, so that is 2n plus 1. And so find the limit. Limit as n approaches infinity. Absolute value of n plus 1 over n is limit n approaches infinity, x square over 2n plus 1 times 2n plus 2. You may or may not write that minus sign, because it's absolute value. That's always positive. So denominator is infinity. So the limit is 0, less than 1 always. Therefore, the interval of convergence is -infinity to infinity, and radius of convergence is infinity. Question number 80. Fx is equal to cos hx. And you know, derivative of cos hx is sin hx, and derivative of sin hx is cos hx. So it comes, it repeats. For f0 is cos h0. Cos h0 is e to the 0 plus e to the -0 over 2, which is 1 plus 1 over 2, that is 1. Then f prime x is sin hx. F prime x is sin hx. So f prime 0 is sin h0. That is e to the 0 minus e to the -0 divided by 2, that is 0. F double prime x is cos hx. So f double prime 0 is 1. We have already shown that. F triple prime 0 sin hx. So f triple prime 0 is 0. Fourth derivative cos hx. So fourth derivative at x is equal to 0 is 1. And this 0 and 1 are repeating. See, therefore, you use the Maclaurin series. Cos hx is equal to 1 plus second term is 0. And next is 1 over 2 factorial times x to the 2 f double prime. F double prime is 1. So it is 1 over 2 factorial times x square plus next term is 0. Fourth derivative, it is 1. So it is 1 over 4 factorial times x to the 4 plus next term is 0 plus 1 over 6 factorial times x to the 6. That is equal to 1 plus x square over 2 factorial plus x to the 4 over 4 factorial plus x to the 6 over 6 factorial plus etc. In some sigma notation, sigma 0 to infinity, x to the 2n. Exponents are 2, 4, 6, etc. That is 2 times n varies from 0 to infinity, divided by 2n factorial. And so an is x to the 2n over 2n factorial. N plus 1 is x to the 2 times n plus 1 over 2 times n plus 1 factorial, which is x to the 2n plus 2 divided by 2n plus 2 factorial. So an plus 1 over an is x to the 2n plus 2 divided by 2n plus 2 factorial multiplied by the reciprocal of an, that is 2n factorial, divided by x to the 2n. And so numerator x to the 2n plus 2 minus 2n, which is x to the 2. Denominator, there are 2 extra terms. The last term is 2n plus 2. Immediately preceding term is 2n plus 1. So that ratio is x squared divided by 2n plus 1 times 2n plus 2. Limit n approaches infinity, absolute value of n plus 1 over an is equal to limit n approaches infinity, x square over 2n plus 1 times 2n plus 2, which is 0. It's always less than 1. Therefore, the interval of convergence is negative infinity to infinity, and the radius of convergence is infinity. Question number 22. Fx is 1 over x. About x is equal to negative 3. That's a question. So you have to use the Taylor series. F prime x is negative 1 over x square. That is f prime negative 3 is negative 1 over negative 3 the whole square. That's negative 1 over 3 square. F double prime x is 2 over x cubed. So f double prime negative 3 is 2 over negative 3 the whole cubed. That is negative 2 over x 3 cubed. And f triple prime x is negative 3 factorial. Actually, that's going to be 1 times 2 times 3. It is actually 6. I wrote it as 3 factorial. Negative 3 factorial over x to the 4. So f triple prime negative 3 is negative 3 factorial over negative 3 to the 4, which is 3 to the 4 again. Then f fourth derivative is 4 factorial over x to the 5. When you replace x by negative 3, you get 4 factorial over negative 3 to the 5. And that also is negative. It looks like all the terms are negative. So you find one more. Fifth derivative is negative 5 factorial over x to the 6. So fifth derivative at x is equal to negative 3 is negative 5 factorial over negative 3 to the 6. Negative 3 to the 6 is the same as 3 to the 6. And so fn 2 negative 3 is negative n factorial. N. So if it is 5, it is 5 factorial. If it is 4, it is negative 4 factorial. If it is 3, it is negative 3 factorial. So fn negative 3 is negative n factorial over 3 to the n plus 1. And therefore, the sum series is sigma 0 to infinity fn a over n factorial times x minus a whole to the n. That is sigma n varies from 0 to infinity negative n factorial over 3 to the n plus 1 times 1 over n factorial fn negative 3. So negative n factorial over 3 to the n plus 1 times x to the n plus x to the n over x plus 3 to the n over n factorial, and n factorial cancels and you pull out the negative. So it is going to be integral 0 to infinity x plus 3 to the power of n over 3 to the n plus 1, and write down an and an plus 1. You have n plus 1 over n is negative x plus 3 whole to the n plus 1 over 3 to the n plus 2 times 3 to the n 3 to the n plus 1 divided by negative x plus 3 to the n. That is x plus 3 over 3. So limit n approaches infinity. Absolute value of n plus 1 over n is limit n approaches infinity. X plus 3 over 3, which is absolute value of x plus 3 over 3, and that is always less than 1. So absolute value of x plus 3 is less than 3. That is the interval of convergence, and the radius of convergence is 3. Okay, so here number 24, that is the last question, and it is again a lengthy one. Fx is cos x around a is equal to pi over 2. We have derived it around a is equal to 0 by using Maclaurin series. So this one is around x is equal to pi over 2. A is pi over 2. So it's slightly more difficult than the other one. So fa is equal to cos pi over 2, which is 0. F prime x is negative sine x. So f prime a is negative sine pi over 2, that's negative 1. F double prime x is negative cos x. F double prime a is negative cos pi over 2, which is again 0. And f triple prime x is sine x, which is therefore f triple prime a is sine pi over 2. This is 1, and this is going to repeat. So next is 0. Next one is negative 1. Next is 0. Next is a 1, and so on. So Taylor series, fx is equal to fa plus f prime a over 1 factorial times x minus a plus f double prime a over 2 factorial times x minus a the whole square plus etc. And replace every other terms starting with the first one are zeros. So it is negative 1 over 1 factorial times x minus pi over 2 plus 1 over 3 factorial times x minus pi over 2 the whole cubed, because the second term is 0, minus every other terms are positive and negatives. Negative 1 over 5 factorial times x minus pi over 2 whole to the 5 plus etc. So it becomes sigma 0 to infinity negative 1 to the n minus 1. First term is negative, so when n is 0, this is negative 1 to the negative 1, that is negative. So that's right. Negative 1 to the n minus 1 over 2n plus 1 factorial times x minus pi over 2 whole to the power of 2n plus 1. 1, 3, 5. So when n is 0, it is a 1. When n is 2, it is a 3, and so on. And now write the nth term. Nth term is negative 1 to the n minus 1. X to x minus pi over 2 to the n 2n plus 1 divided by 2n plus 1 factorial. Replace n by n plus 1, you get n plus 1 is going to be negative 1 to the n plus 1 minus 1, that is negative 1 to the n, x minus pi over 2 times 2n plus 3 divided by 2n plus 3 factorial. Therefore, n plus 1 over n is negative 1 to the n, x minus pi over 2 to the 2n plus 3 divided by 2n plus 3 factorial multiplied by 2n factorial, 2n plus 1 factorial divided by negative 1 to the n minus 1 times x minus pi over 2 to the n plus 1. That is negative because of the negative sign, negative, but that negative doesn't matter. Negative x minus pi over 2 to the 2n plus 3 minus 2n minus 1. It is going to be 2 divided by the last two terms will stay. This is 2n plus 3 factorial. So the last term is 2n plus 3. And immediately preceding term is 1 less than that. That is 2n plus 2. Now find the limit. Limit n approaches infinity. Absolute value of n plus 1 over n is limit n approaches infinity. X minus pi over 2 the whole square divided by 2n plus 2 times 2n plus 3. And the denominator is infinity, so it is 0, is always less than 1. Therefore, the interval of convergence is negative infinity to infinity, and the radius of convergence is infinity. Okay, so that is the end. and your final is on August 2nd. It's a Sunday. You have to adjust your schedule, and you have 2.5 hours to finish the final. There will be around 25 questions. 50% of the final is from chapter 11. So keep that in mind. I know chapter 11 is new to most of you because series and the sequence, you haven't seen it, especially the advanced topics. And so pay attention and prepare well for the final, and your grade will be posted on August 3rd. Okay,